and the floor is yours.
Thank you, Professor Doulos. The title of this presentation is Planning an International Dark Sky Place in Aenos National Park, the first steps. Of course, this presentation concerns something that is related to light pollution. Light pollution is a very well-known concept to all participants of this session. It is a problem that we now know and have very solid scientific data that it affects not only astronomy, which we always knew, but also our health, the ecosystems, wildlife, and other factors about life in the city. If we take a look about how widespread light pollution is, we can see that looking at the map of Europe, we can see that Greece is relatively lower polluted than Western Europe, but still we have a lot of light pollution, as you can see in the thermal map in the middle, in all city centers. Of course, Attica is very, very light polluted, and so are the urban centers of Thessaloniki, Patra, Volos, Larissa, and other major cities. However, in the darker blue areas of the thermal map, you can see that there are spots where light pollution is much lower. For instance, in the central and southeast Peloponnese, in central western Greece and western Macedonia, as well as some islands and South Crete. One of these areas is the area of Kefalonia, the island of Kefalonia, which appears on the right map. As you can see, we have the capital Argostoli that is very light polluted, and we also have some light polluted areas in other settlements like Poros, Kala, Sami, and Lixouri. However, most of the central part of Kefalonia is relatively dark, including the area of Aenos National Park that appears in a green color at the left of the map. The idea was that this place in Aenos National Park would be ideal to create an international dark sky park. The International Dark Sky Parks is the flagship activity of the International Dark Sky Association, which is the oldest and a major organization that tries to fight light pollution. There are more than 100 dark sky parks in the world. Most of them are in the USA and Central and Northern Europe, but the pace of new parks is increasing every day, and our intention was to create the first dark sky park in Greece. In order to do that, we had to make sure that the national park of Aenos is dark enough. The most prominent method with which one can measure the darkness of skies is by using the device called the sky quality meter. It is a portable photometer that measures visual magnitudes per square arc second. It basically has a scale, if you can see on the label on the instrument, that ranges from about 16 in the most light polluted areas to a bit over 21 in the darkest areas. So the measurements that we took in various points inside Aenos National Park measured that the average of the park was 21.35 in this scale. The cutoff limit that IDA has implemented for a dark sky park to be acceptable is 21.2. So not only do we meet the average requirement, but we also have a safe margin. Our best measurement was 21.45, which was deeper in the park, as I will show in the next map, and the worst was 21.25. This is the map of the most important measurement sites. As you can see in the right part, the mid and deep park positions that are further away from the capital Argostoli recorded better values of 21.45, while areas on the left part, which are closer to the capital Argostoli, recorded lower values, even up to 21.35. However, all the park is over the 21.2 base limit. We've verified also the darkness of the sky by taking long exposure photographs that provide very rich views of the stars and the Milky Way. One other thing that is necessary is to estimate the quality of the sky visually. Visual estimation is based on the Bortle scale, which is a scale implemented by an amateur astronomer called Bortle. And to make this assessment, one must determine what objects are visible in the night sky. So by determining the exact amount of stars, some dim galaxies, and some other details in objects, we quantified the dark sky of Aenos to be Bortle class 3. It must be noted that in Greece, there exists no class 2 or 1, unfortunately. Greece is a small place, and you cannot go farther away than major cities than 100 kilometers. These skies can be found in areas, even in the USA, where there are dense areas, but there are also areas where for hundreds of kilometers there are practically no settlements. Also, we needed to record light pollution up the horizon. Of course, Aenos is a very high mountain, the highest mountains of the Ionian Island, and from the top of Aenos, you can see cities in the horizon. We recorded them, but found the effect of light pollution to be no more higher than about 10 degrees. One other major requirement was to make a lighting inventory of the national park as well as the surrounding area. We're fortunate that the park is not lit, so it is easy to meet lighting requirements inside the park. It must be noted that most national parks in Greece are not lit because typically access during the night is not allowed in forest areas. But we did a very detailed survey of the lighting in the island of Kefalonia, and we found most of the malpractices that one can see in Greek cities and small towns. Most of them are familiar to you. Regarding the type of light sources we found, in the capital Argostoli, we found pretty much all light sources, including old ones like sodium and mercury lamps, even new ones, LED lamps, as well as transition lighting like mercury lamps that were replaced with compact fluorescent lights. We pretty much found an array of everything, every light technology that has been used in the last decades. Also, we had a variety of color temperatures, ranging from very cool to very warm light temperatures. In this map, you can see which types of light sources we found in each major settlement in the island of Kefalonia. What was mostly important was the measurements of illuminance and luminance that we did in the most important areas of the island. In this table, you can see the luminance measurements that we performed, and it is very obvious that in places like Argostoli, we have very high luminance values, and in other places that are away from the city, we have very low luminance values. However, we also have very low uniformity values in those places. So if we were to sum up the lighting of Kefalonia, we could say that there is over-illumination in city centers, sometimes extreme illumination, like in the city of Poros, where we measured more than 400 lux in the main square. But areas away from the city centers are under-illuminated with low uniformity. However, light is very poorly distributed. We have luminaires that distribute light very poorly, so although they under-illuminate the areas of interest, they also cause light pollution. We found many luminaires with very blue-rich radiation, many cool compact fluorescent lamps that were installed replacing older lamp technologies, and also many malpractices in the new installations of LED luminaires, mostly concerning very high intensity LEDs and cold color temperatures. This photo that we took in the morning after our measurements in the capital of Argostoli had finished is very telling of the situation. You can see an array of blue, yellow, and greenish and orange lights that pretty much show that there is no actual planning of where the lighting of the city goes, but it is pretty much a go-and-see situation where lamps are replaced as they burn out with whatever exists available at the moment, and not much planning, neither regarding light pollution and neither the quality of lighting in the city. I'm happy to say that last week we submitted our final application to make Aenos Dark Sky Park an international dark sky park, and we're waiting for results in the coming 2 months from IDA. Thank you very much.